Welcome to qnawire.
In this question, we are told about this reaction to purify gold. Okay, and we are given the relevant half reaction. The first one is AuCN 2 minus plus E minus to produce Au plus 2CN minus, and the reduction potential for that is minus 0.60 volts. And the second one is zinc Cn4 2 minus plus 2 electron to produce zinc plus 4 Cn minus, and the reduction potential for that is minus 1.26 volts. Now, based on this, we have to calculate the the reduction potential for this reaction, as well as the delta G for this reaction, together with the equilibrium constant for this reaction. So how can we do that? And this should be Cn4 2 minus. So how can we go about doing that? One thing that we need to do first is to look at this equation and figure out how we can arrange these two equations to give us this. Okay. AuCN is on the reactant side here. It's on the reactant side in the equation. So this equation is fine. ZnCN4 2 minus is on the product, but it's on the reactant side here. So we have to flip this equation. So you gotta flip this. So flipping this equation will make it look okay. And another thing to remember is that in this equation, we need two AuCN2 minus, and we have 1. So we need to multiply this equation by 2. So this is the processes that needs to be done. Multiply by 2 and flip this. Okay. So let's just go ahead and do that. So we're going to have Au 2 AuCN 2 minus plus 2 electron to produce 2 Au plus 4 Cn minus. And doing that will lead to the multiplication of the reduction potential as well. So this will be minus 1.20 volts. And when we flip this, we will have Zn plus 4Cn minus to produce Zn Cn4 2 minus 2 of it. We're not multiplying, plus 2 electron. And the reduction potential for this will be positive because we flip it, so that will be 1.26 volts. Now, we need to add these two equations together. Okay, so when we do that, we have zinc, we cancel, so zinc is not cancelled. Okay, what will happen? 2 electrons, we cancel 2 electrons. 4 Cn, we cancel 4 Cn. So we'll have 2 AuCN2 minus plus zinc produce 2 Au plus zinc Cn4 to minus, which is the same equation that we have here. Okay, and we need to add the reduction potentials together. So minus 1.20 plus 1.26. So this will be 0.06 volts. So this is the delta E for the reaction. Next, we need to determine the delta G. So delta G is minus NFE standard. In this reaction, the number of electrons that was transferred is 2. So delta G will then be equals to minus 2 times Faraday's constant 96485 multiplied by the E for the reaction, which is 0.06. And that will give us so this will be 115.78.2 joules, which should be 123. That's 1, 2, 3. 11.5 kilojoules negative. Then the next thing will be to determine the K for the reaction. So we also know that delta G is minus RT ln K, right? Which is still the same thing as minus NFE of reaction. And this is of reaction 2. Okay, so that means that minus RT ln K is equals to minus NFE reaction. And then ln K will then be equals to minus NFE standard of reaction divided by minus RT. And K then will be equals to the exponential of minus NFE standard reaction divided by minus RT. So let's just cancel out. All right, so let's figure out what this would be. So this would be K will be equals to exponential, and we've calculated this to be 11578.2 divided by R is the gas constant. So that's 8.314 multiplied by 298 Kelvin. Okay. So this will be 107. So K is 107.